Swayam Prabha. Digital India. Educated India.
Good evening everybody. Today's lecture is hydraulic circuits and valves, and this is under module 3 hydraulic valve in general. Now, today I shall discuss that how the circuit is designed using pressure control and flow control valves, or using a set of valves, how we can make various possible hydraulic circuits. Some exemplary circuits also will be discussed next. Actually, we can make various circuits. In fact, whatever work we would like to do, we have to select the valves and we have to place that valve at proper location to achieve the performance. Now, first I shall discuss a venting system. This is with mostly pressure control valve. Why I should say mostly? It is with the pressure control valve. Apparently, it will look like a pressure relief valve, but we will find there is some constructional difference with a ordinary pressure relief valve and these valves what I am going to show in this lecture. Now, we know the meaning of venting. Venting means we should bypass oil or in case of gas due to some reason. In this case, venting is done usually when we are not operating the load. How it is done? What I have shown here, a circuit. Here as if this is a, from the symbols, as we know, this is a pressure relief valve. Okay. Now, this pressure relief valve can be operated from the remote by allowing a flow through this valve, and then the flow to the main system will bypass to the tank. In more details, the inner construction of this valve, which is being used for venting, which is a pressure control valve, almost the function is like a pressure relief valve, looks like this. Now, here first of all, if I compare with the circuit, then in this valve usually instead of connecting like this, usually there will be through passage. That means, we can directly put one end of this line here and other end on the other sides. Now, I have written here from pump. So, oil is coming from pump and it is going through the main system. Okay. Now, what I find inside there, a stem or a cylindrical body is there. In that cylindrical body, what we find, there is a piston. In that piston, there is another hole which is like an orifice, okay? And at the bottom, what we find that this passage is connected to another path in which there is this stem is extended, this piston is extended, and apparently it is closing this valve. What else we look into this stem, that there is a hole also inside, and as if some sort of light spring is there. This one is a light spring, and there is a hole. That means this is directly connected to end of this. Okay. Now, ordinarily this will work as a pressure relief valve, as long as this is closed. Now, we should call venting along with this valve, but basically you can say this is working for the venting process. This is again with a non-return valve, with a check valve, so that no backflow is possible to this side. Now, what happens? Let us consider it is initially closed, then the oil is flowing through this, oil is also coming this side, this point is closed, that means it cannot go, oil cannot go this side, there is no flow, there is a setting pressure, this is pressure relief setting pressure, say 10 megapascals. So, first thing what will happen, when the pressure in the system exceeds 10 megapascals, then this will open. Once this opens, then there will a flow will begin. As there is a flow in this side, then there is a pressure drop here. So, this piston, which is having exposing equal areas from both the sides, will have a thrust upward. So, with this upward thrust, this will move and oil will go to the this oil from here, it will go to the tank. So, this is actually you can call pilot operated pressure relief valve. Okay. Now, with that, how we are doing the venting? While we want a venting, then a remote control actuates this one, then this opens. So, venting position opens. Now, this venting position opens means the oil start flowing there, but this is not open. Once oil start flowing there, again this will open, again this will open, and this oil will go to the tank. That means, at that time it is pressure may not be the set pressure, it is maybe below set pressure. Usually it is the ideal conditions when we need to vent the oil. This is used with the fixed displacement pump. Why we use fixed displacement pump? This to keep the circuit always ready with high pressure oil, and frequent operation is there. But when we, due to some reason, we want that to vent the oil, and we keep on running the pump, but we would like to vent the oil at low pressure, then we remotely operate this one, and then oil is passing through the tank through this valve. Now, here another note I have written, float piston allow flow to tank only at 0.137, it will be megapascal, sorry, this 0.137 megapascal difference. This is, or in other words, it is 1.37 bar, 1.37 kg per centimeter square. So, I have forgotten to indicate that pressure unit. Okay. So, is that clear to you that how it is venting system is working? Now, usually you will find that in pressure relief valve the construction is almost same, only there you will be a drain passage or so. This internal draining is also there in PRV, but sometimes external draining will be there. However, another important thing is that whatever may be the pressure this side, that will try to pull this one, because if you think of the load balance, this side load and this side load, that is a differential load which we balancing the piston. In normal case, when there is a no flow, equal pressure, but there will be pressure from this side. To balance this, there is a hole, and other side also same pressure is there. This area and this area is same. So, this will at the condition when there is a no flow, it will be in its position, steady state position, equal force from both the side. With the light spring, it is closed and oil is not going through this passage. Okay. Now, we will come to the next operation, that is called sequence circuit. Now, here I have drawn a circuit. You can understand that there is a cylinder A, there is a cylinder B, and from 4/3 DC valve, this is 4/3 DC valve, and X, Y are the solenoids. We have solenoids both side, and both side we are having the spring, then that means it is a spring centered. Okay. Now, this straight connection, that means when we will be in the right side, then this is connected to both the cylinder rod end side, whereas for the cross connection, this pump will be connected to other side, that means the piston side. Okay. Now, cylinder A and B are operated in sequence. We need to operate this in sequence, either cylinder A first or cylinder B. In this case, actually cylinder A first and then cylinder B. This means that if they are of equal size, there will be definitely there will be some pressure difference for operations. Okay. So, what we do, we use a sequence valve here. Again, it is the basically the principle wise more or less same as that of the pressure relief valve. Now, in this case, first of all, let me explain the valve. If we consider that the flow, say first of all what we at what time the flow will start, initially there is no flow because this is a closed center. Okay. Now, what we do, we say we have connected the X, the X solenoid is operated, piston of cylinder A moves to right to its full extent. Now, this oil is going like this cross connection is there. So, oil is going through this, it is going through this valve, it is trying to go here, it also trying to go here. Now, at this position, what is there? There is some setting is there, this setting is there. So, unless we reach that setting, this oil will not go through this point. Then pressure is built up further to set pressure of sequence valve. We have set a pressure setting is there. So, oil is now will try to pass through this, but it cannot, it will move the cylinder A to its existing positions, and now pressure is building up. Once the pressure is built up, then oil will go through this, then it will operate the B. Piston of cylinder B moves to right to its full extent now. Okay. Then when solenoid Y is operated, that means we are allowing oil in the opposite side, then the both cylinder A and B retract to left at a time or one after another depending on resistance. It might be some residual load is there. If they are perfectly all right, they can return at a time, or depending on the resistance, one will return to the other. In that case, say this we have connected now this, the oil is going back through this one, which is almost no resistance is there. Now, this means that this return flow is shown here, oil is returning here, okay. But to go the oil to this side, what will happen due to this pressure balance there, it is like a relief valve, this will open, this path will be closed and then oil will go to this side. That path is not shown of course, but this oil no through this path, through this path it will go, this will go, okay. This will open and it will go. Apparently this position is shown, this oil is passing through, it is bypassing, not to this passage, it is going through this check valve. This is not very understandable with comparison to this, but actually for operating cylinder B, this spool has to open and then oil will go like this, and what the path is shown, this is return path. Okay. In case of this forward flow to cylinder B, this will be opened, which also can be actuated by a remote control. Here this is there. Say sometimes we may need to operate cylinder B out of sequence. In that case, this path is connected. Okay. Now, flow from piston ends of both cylinders go back to tank in cylinder of B via check valve. Okay. So, this is for the return path, I have written this note. Now, we are coming to the sequence circuit valve actually. Now, this valve already we have studied that this valve may be without check valve. The sequence valve may be without check valve, that is for only one side flow. Of course, that we have to see that when is oil is coming back, in that case we have to find out some other path. Here what we have done in this case, we have used a check valve which is apparently integral part of sequence circuits, the earlier which I have shown. If we would like to use only this valve, only sequence circuits with without non-return valve, in that case we have to use a separate path for return oil from the cylinder B, that might be low pressure relief valve, that is possible, or separately we can connect a check valve there, it is possible. Okay. Now, this function already we have learnt, this is nothing but just like a pressure relief valve, the flow is coming in. Okay. Now, referring to this figure, the sequence valve can be externally piloted, we can externally operate this one. This means that when we are giving the signal here, this is moving and oil is going out. Okay. Now, basic principle is that here the connection, this in case of external operation, we have to first of all we have to plug this one, then oil is coming here and this side and this side pressure are same. So, it is not moving. Now, if I excite externally, then this will move and oil will go. At what pressure it will work? Depending on the setting we have done here, it will work. Now, there is an external drain also. This oil is always will go through the external drain passage. In some cases, this external drain is not preferred, and in that case we put the internal leakage path, okay. Then oil will go through this. Now, this is only in one direction. So, without check valve, if we look into this, it will operate only in one directions. Now, if I want to operate this with the internal piloting, in that case we have to plug this one and we have to open this one. Okay. Then oil will come here, again we will find this side balance and there is a very small passage, and here is also, this is not very clear, but again if we allow the oil from this side also, this will be balanced, it will not move. But when certain pressure will increase, that means here this pressure differential will be such that it is able to move this one, then again it will open. So, in this case what we find, both internal and external piloting is possible. Now, external draining is must to avoid back pressure. Okay. Now, here I have shown a little detail that if we look into this valve, this is closed. Okay. So, the flow is coming in, we look here, the flow is coming in from this side. Okay. Now, then this is internal piloting, it has come over here, this is being balanced, it is not very clear from this, but it is being balanced by the pressure here and also here and here. Look into this, pressure is going through this, oil is going through this, it is coming over here. So, this side and this side is balanced, and oil pressure is here and here, this side is also balanced, unless there is a flow. Now, how the flow will begin? When this pressure reach a certain level, so that it can move through this, there will be a little opening and external drain will start, flow will begin, pressure will drop here, then this will open. So, this is the open position. When this is opening, then oil is going to this side. It might be secondary circuit. Again here I would like to say that this valve is constructed in that way, instead of side fitting or tap fitting, we can directly fit one side, input side here and output side to the system here. Okay. And you can have a look into the symbol, how the symbol is. Is it clear somewhat? I will give you this picture and you can study this. So, system is like that, here it is not shown, but here it is shown clearly that there will be a passage, in fact there is also a passage. So, oil is going like this, oil is going this side. So, initial condition we should draw that everything is red here, but anyway they have used these two colors. So, this means that all side pressure are equal, it is in balance. When only this pressure exceed to move, there will be a this pin is there, it will move and then oil will start flowing through this, and then it will go to this path, and this is for external draining. In any way it is shown here closed. In a carefully designed valve, internal draining is also possible by removing internal D plug while XD is plugged. We can, this is plugged and we can internal drain, that means we can have this passage connected, it is not shown here. Now, this the same valve, if you look into this construction, what we find here, only a check valve is used there, otherwise construction wise it is same as before. Now, this check valve, once we use this check valve, what you find that the flow in from both the sides and out from both the sides. This means that with this check valve we can allow the flow from this side to this side. Now, this check valve is operated with the external force. we externally operate this check valve to flow to both the directions. So, oil is going from this side to this side, as well oil can come from this side to this side. So, this is the sequence valve which we can use. The circuit already we have shown. Okay. Now, in this valve, what this check valve is there, as well as there is auxiliary external port pilot. In this case, what we find, this valve is normally with internal piloting, but as well there is also external piloting. This means that we can change the sequence norms. That means, whenever we need, we can externally operate that, and we can also operate the cylinder B not in sequence or according to our desire, but according to our desire. A significant difference in the valve as shown in this figure, which as the auxiliary external pilot is directly exposed to the bottom of the larger section of main valve. Okay. Contrary to other two, this gives dual control. We get dual control. One is that the sequence what for we are using this valve, as well as external control. Now, there is also a two-stage sequence valve. Now, in that two-stage sequence valve, it is also named as Y type. Now, here if we look into that venting system, if you remember that venting system, what is the difference between that venting system and this valve? Can you say? The basic difference is that we do not have connection here, we have an external drain. In this case, we have external drain, not it is connected to there. In venting system, this was connected to there. In pressure relief valve also, this connection will be there. Let us read it, what it is there. Pilot operated sequence valve differs from pilot operated PRV. The drain passage is external instead of through stem of balance piston. This is called balance piston. The primary system flow passes through below the piston land. That means, this is the primary system, this is going to the system. Okay. I have already explained this, these are available in the valve system that we can connectly direct to the system. With secondary system connected to the bottom port. Okay. Sequencing occurs at about a pressure of 0.137 megapascal, that is 1.37 bar over the setting pressures. Now, in this case what is happening, that we are keeping it close. Now, only when the pressure, setting pressure reaches here, in that case this piston moves and the flow begins to allow to the secondary circuit. And here also, as I have explained, to keep this stem in balance, there is a small hole, so that pressure this side and pressure that side remains same. As well, there is also spring, because this is actually, this will be a balanced piston. Now, ordinarily when there is no flow, this is completely balanced, there is no force acting on that except that spring force, that is just to allowing this to sit on these positions. So, when this flow is there, this seat is like that, ordinarily it will not leakage, with a small force it will remain closed and there will be no leakage. Okay. Only if there is a flow, then this will move and this will be operated. And for operating this only we need a very small pressure difference, and as we need small pressure difference only then it remains balanced for longer time. Otherwise, as we know that once this flow begins, this gradually this pressure will also drop. You see, in a system, once you say in a tank there is a pressure. Now, if you make a hole there, immediately inside pressure also will drop. Now, secondary system pressure below the piston is sensed at the top of the stem. Here secondary pressure has no effect on piston movement, which I have discussed. Thus, piston remains at position until the pilot needle cracks at set pressure and pressure drops at upper chamber and the piston is lifted, allowing secondary flow. This flow we call secondary flow, that is to the say cylinder B. Okay. Now, we shall study some circuit with pressure valve. This is counterbalance valve and counterbalance circuit. What I have shown, this is the counterbalance circuit and system. Now, this is also we can call, this is somewhat sequencing and called as counterbalance system. This system is called counterbalance valve, but the valve principle, as you see, there is a pressure relief, non-return valve and the same as pressure relief valve. So, this also some sort of sequencing valve, but here the purpose is different. In that case, it maintains resistance against flow in one direction, whereas allows free flow in other directions. It is usually placed at the rod end side of double acting actuator. This is a double acting actuator and the cylinder we have placed in vertical directions. It can be upside down also, but this is not for horizontal work. Normally, where we are lifting load, there this counterbalance is used. Why the counterbalance is used? This prevents the free fall of load, that is uncontrolled movement of load towards the gravity. What will happen? You know that if you must have seen in a crane, suppose then when we release the brake of the load lifting hook or the drum, then it will start falling, and as you know, due to the gravity it will start accelerating. And when it will touch the ground, there will be severe impact. To prevent that, we must control the load. In that case, in case of crane mechanical system, we use the brake. There is a brake that when it start falling at a higher speed, automatically that brake will be engaged. Once this is engaged, then again the force will act on that to release that one and the load will fall, and by that it will balance, it will control the movement. Okay. Now, this circuit is shown here, it is something like that. So, when it is lowering load, let me explain what it is there. First of all, we have used a DC valve, direction control valve, which is fully open, and again it might be solenoid, I have not shown here, it might be manual or it might be hydraulic, that does not matter. But what we have used here, this is a open center valve. Now, this flow is normal conditions. When we will not operate this valve, then this will oil will go to this. Now, this is again we do not need very fast response here. We can slowly lift the load and lower the load. This purpose is, main purpose is that handle this load, not very fast operations. So, we can go for open center to save the energy, right. Now, we are now think of lowering load, because that is the main purpose. So, while we are lowering load, we allow this to tank, that means we will go to the left hand side. So, it is connected to there, I mean this side is connected to the tank and the pump side or pressure side is connected to the other way. Now, while this load is being lowered, how much pressure we need? Practically we do not need the pressure. What we need? We need the flow, because this is to be filled, otherwise it will not move. On the other hand, to prevent the load free falling, this oil will try to come this way, but it will not be able to go, because this is a non-return valve. Then oil has to go through this pressure relief valve, and the setting is such that depending on this load, this setting is there. So, this might be again controlled from the remotely controlled, and the load will come down by blowing this valve. That means, there will be restricted flow. Now, if there is a, suppose if it wants to speed up, then there will be, due to this flow, we need to have pressure increase in that, again this will be closed. Now, here we have seen the we have shown this valve. This is the direction control valve here, and this is the counterbalance valve. This one is the counterbalance valve. Now, what is happening? That what I have explained. If you look into this, then oil is through this valve is going to this side, whereas oil coming through this, and through this restriction it is going to the back to the tank. This is tank path is not shown, but if you look, if you study this, this is nothing but some sort of a sequence valve. Operation principle is same, and here as well you can see that external draining and internal draining is shown. If we external drain, for external draining, we have to open this, we have to close this, this path is there, and as well as also internal piloting and external piloting is also possible. So, this is basically a sequencing valve, but application is different. Now, also it is possible that while we are using this valve, we can use another valve which is called slow down valve, but the feature is not shown. In that slow down valve, it is there is a spool that with the increase in velocity, that spool will experience a load, and that will close the path. Once it closes the path, again the velocity of fluid will decrease, again the force will reduce, and that will open. That is a very simple in comparison to that, but this is having the external control, but that valve is not having external control. Usually that slow down valve is used where the loads are limited, say in case of forklift truck, when the load is being lifted, there we can use that slow down valve, but that feature is not shown, but basically that is also called counterbalance valve. So, at least you can understand what is counterbalance valve, what is their applications. Now, if I here, perhaps it is wise to discuss that in your question what will be there. So, probably you have to what is a short note, or maybe a part of the question is that what is counterbalance valve, explain with a circuit. You can draw a circuit and you can explain these few words. Okay. That you have to, first of all you have to understand how it is working, internal feature of this valve and how it is working. Okay. Now, we will go for unloading. That was a counterbalance. Now, we will go for a unloading valve. What is unloading? Now, usually in any fluid power system, we need to go for energy saving process. Now, in many operations you will find that there is sometimes we need to actuate more load and other time maybe lower load. Once there is a low load, I mean low capacity load, then we can increase the speed, we can have this because we have a fixed motor, that motor full energy we can use for that purpose. If it is allowed that we can move the load at higher speed, then in that case there should have some system that we can either control the flow or we can have system when there is a high pressure only certain amount of flow, when there is a low pressure we can increase the flow. That is possible variable displacement pump, but variable displacement and pump is costly, expensive, as well as that control is also difficult in comparison to this system where there is a high pressure pump and there is a low pressure pump. Idea is that when there is a load is more, then full power of this will be utilized, full or the maximum power will be extracted from this motor to run the HP motor, and that will work and load will move at slow speed. And then, but this is connected to low pressure pump also. This low pressure pump oil has to go somewhere. What it would do? It should bypass the oil, it should drain the oil at a very low pressure relief. But if we use that very low pressure relief here, then again it will not be work when we will need this flow. Suppose the load has decreased, in that case it should automatically work such that both this flow and this flow should mixed up and should operate that one, the load. Now, let us see what is there. This is called unloading valve. Now, what I have shown here, say this unloading valve, this is the symbol, and we can see this whole unit is called unloading valve. It is also a pressure relief valve, but it looks like this. Now, primary port from LP pump. Basically, here what we are doing, this unloading means we are unloading the flow of low pressure pump to the tank. This is the purpose of unloading. It is no connection with the high pressure pumps. Now, how it is working? Now, you have to compare this with this figure. This is the check valve and this is the connection to this to operate this one. This is the pilot connection. Now, this primary port from LP pump is connected to here. So, ordinarily when this is a high pressure, this is blocked, the no oil is coming to this side, but only it is remotely trying to control this valve. Okay. Now, again this pressure is not sufficient to open this one. If it is not sufficient to open this one, then this will remain closed, but if there is a high pressure, this will open and then oil will go to this, is not it. Say let us consider that this pressure setting here is 10 megapascals and system pressure is more than that, then this is not being operated. Sorry, I have made mistakes. This is 10 megapascal, it is working at a high pressure. Now this same pressure is coming over here, and then at that conditions this is being opened, rather this is being opened. Do you understand? Pressure here more than here, the setting is 10 pressure here more than 10 megapascals. So, this is being opened, 11 megapascal. So, it will open. So, flow is going to this, and so this is unloading, this coming from here to here. Now, this is secondary port to tank. Now, this is the main system I have already discussed. Now, main system pressure is higher than set pressure. Only HP pump flow is being used. So, no flow through this check valve, and this is being operated, I have discussed already. Now, we will come to the other positions. Now, suppose this pressure has come down below this set pressure, say it has become 9 megapascals. Once it is 9 megapascals, then this cannot open this valve, okay. Then this flow can go through here, it will be mixed up. Now, it should be, it is interesting that this is a basically low pressure pump, and usually this is a high flow and this is a low flow, but it is like that when this will operate and this will operate at pressure, say setting pressure below 10, then total power of this will be equal to the motor power. So, this is, by this way we use the, I mean optimize the energy consumptions. So, this means that unloading valve is to unload a usually a low pressure pump when there is a high pressure and load is being used only from the high pressure side. Now, this is one application, there might have some other applications also. Okay. Now, in brief we can say that an unloading valve is also another version of sequence valve, what we have studied earlier. It allows the pressure to build up to a value determined by a pressure setting. Okay. Then it is two-way valve generally used to bypass part of this circuit back to tank at very low pressure. So, two-way means that we have shown that there is a passage is interconnected and it is also connected to the high pressure side and low pressure sides. So, construction wise it will be slightly different from the sequence valve or pressure relief valve. The internal draining occurs, and double pump system as shown in figure is an example of unloading valve. This is one example. Using the same power, two output are mixed up at low pressures, and at high pressure only the flow of one pump is used by the system, whereas the flow of other pump is diverted to tank at a nominal pressures. Now, again I would mention here that what might be the type of questions. You have to draw a circuit like this, you have to write these few words, and if it is additionally mentioned, you have to draw the internal features of that valve. Now, usually if the internal features of the valve are asked to draw, that is usually a full question. But this might be a part question or short note type questions. So, again I suggest you to read it thoroughly, to look into the construction of the valve, so that if you ask to write, that you can write these words and as well as you can show this figure. Now, next, circuits using flow control valve. So far I have used the pressure control valve. So, now we will come to flow control valve. Flow control valves are used in three basic ways in circuit designs. One is that meter in control. You can understand from the words that meter in control, that means while we are allowing the flow inside the system, it will be metered, then meter out control, and then bleed off control. These have specific applications. Now, let us consider the meter in control. In that case, what we find, what is this valve? This valve is 4/2 valve, 4/2 valve. It is just operating this double acting cylinders, but we have put a flow control valve in line. Okay. Now, the flow of the fluid can be controlled as it enters the cylinder or motor, making it a meter in applications. Example, operation of a grinding table or a welding table. That means, when we are grinding, we need to control the speed while the grinding operation is being done, whereas for the on the other hand it can move faster. In that case, although there is the control, I mean it is this control in both directions, but at that time there will be low pressures. So, and also as well as the area is less, in that case it will return very fast. So, while it is grinding or welding, that will operate at slow speed and with a controlled flow. Now, this is a picture, as you can see this, the high pressure oil is going and then it is being controlled. Always you should remember that when this is control means this side pressure becomes equal to the pressure of this relief valve, set pressure. Say if it is a 10 megapascal, this side 10 megapascal, whereas this side it will be less, pressure will be less. Now, meter out control, as you see that we have used the control flow control valve in the other side. Now, meter in control, that fluid leaves the cylinder with a control flow is meter out. Now, it is widely used in machines, tools, often as a quick return mechanism, because we can control this and we can vary this return time. Also, it is commonly used on drills. When the drill point is about to break through, it tends to drag, but metering the flow out of the cylinder prevents the drill from a fast breakthrough of the material being drilled. This sentence it might be difficult to understand, but I am explaining that this is like that while this is being operated, this side pressure and this side pressure will balance this force. That means, this is not for the rotation of the drill, rather the feeding of the drill. Now, this is controlling the force, but still it is moving in the forward directions, not applying much force, only it is applying the required force. Suppose there is it requires more force, then this will be controlled in such a way that there will be pressure difference and force will drive the drill to pass through that. So, usually this is again we should have better knowledge of cutting material removing process by drill. In that case, what happens when it gets stuck, then there is a back force on the drill. So, this can be controlled better way by meter out. Okay. Now, this is again a meter out circuit. You can see this how this is a pressure this side, there is a low pressure this side, because of this flow pressure will be, but still pressure will be generated. If we do not use this one, no pressure will be there, but if we use this flow control valve, there will be pressure as well as the motion will also be controlled. Now, here I have shown, you can see this figure, I will give you the note, from there you will have a better understanding, but if you look here that it is 1000 psi this pressure relief valve set, here it is a 10 gallon 37.85 liter per minute flow is there, and here pressure is 1000 psi setting pressure. So, as this is a flow control valve, it will normally go to the set pressure and there will be some flow from this side, because this is being controlled, position is being controlled. So, some flow has to go this side and it is at full pressure. Now, here the 2-inch pistons, therefore, force is 2000 pound. Now, this side in normal course it can go up to 2000 pound, that means here pressure, if you look into this will be very high pressure this side, because there is a only 1 inch piston. This rod area will be subtracted from the pistons. So, what will happen in normal course when the drill is moving? We do not, if you have operated a drill, if the material is good, you will find, and drill is properly sharpened, you may not apply much forces, but whenever due to some reason or you have given a more feed by hand, you will feel that it needs more force. Once it is there, then there will be force balance and this motion will be restricted, it will not be moved further, as well as this pressure difference will be there. So, automatically again it will try to give more force, but it will not allow much movement. So, it is the meter out is used in this way. Now, we will come to a bleed off control. In bleed off control, what we find that this is externally we have used a flow control valve. Now, if we operate this one, then flow will pass through this valve, and this can be used for both directions, while that means this is a combination of meter in or meter out. Okay. What we can do in that, instead of allowing control flow, we are controlling the drain flow here. Now, diverting the flow of fluid to the tank is known as bleed off functions, used in planer table or broaching machines and planing table. You would have seen in case of planing machine or broaching machines, what moves? In case of broaching machine, of course, the broach moves. In case of planer table, the table moves, not the job. And if we in brief, if we study, so this is a bleed off circuit is shown here. If we in summary, we can say the meter in and meter out circuits are not very efficient, although accurate. These are not efficient, not energy efficient, I must say, but these are accurate operations, both meter in and meter out. On the other hand, bleed off circuit is efficient, those are efficient, but not very accurate. We cannot have accurate control over there. So, we must think of specific applications. The meter in circuit can control overrunning, only this meter in circuit that can overrunning, say in case of drill what we need, and can oppose loads, as I explained a little bit. And in other two cases, that means meter in and bleed off, they cannot handle opposing load. I mean, if the load is there, then they cannot make much control over that, only they can control the flow. The choice of location of flow control valve is important. We have to put these valves in proper positions to make it meter out, make it meter in, or make it bleed off. So, maybe the same flow control valve you are using and the same circuit, same cylinder, but using this flow control valve at 3 different positions, you can make meter in, meter out and bleed off, and you can handle the load in different ways depending on the purpose. If you look into the planer machines, there is purpose is different. If you look into shaping machines where the tool head is moving, there is it is different and load is also will be different. In case of drilling, as you know that if you allow the if feed is increases, then more load will be experienced, and particularly at the time of breakthrough, means when the drill is being finished. Suppose you are making a through hole, you may not get problem while it is the mid positions, but when it is just finishing the hole, that time you will find that it is require extra load and thrust. So, and it is going for overrunning, and at that time meter out flow will be the best. So, thank you. Here we end today's lecture.